Okay, so let's continue with our next video in coding exercise series. So in this video, we will solve the next problem, that is climbing the leaderboard, which is on the hacker rank, and this is on the medium category. So this is not a easy one, though it's easy if you read the question, but they have mentioned medium. I will tell you like why it is medium. Right, so medium is correct, but let's go through the question. An arcade game player wants to climb on the top of the leaderboard and track their ranking. Okay. The game uses dense ranking, so its leaderboard work like this. So there is a leaderboard. What is leaderboard? So you have some leaderboard where you have the rank and the who rank first, who rank second, who rank third, and what is the score of the player who rank one, what is the score of the player who rank two. So that is called a leaderboard. And the leaderboard use dense ranking. So what does it mean by dense ranking? Dense ranking generally means like a player who scored equal scores. So let's suppose there are two player who scored equal. So are we? Let's suppose uh, maximum like score a person can earn is 100. So there are two players who score 100. So shall we assign both the players rank one, or shall we assign player like any player one and another player two? So dense ranking means we are going to give the same ranking number if the scores equal. So if the score is equal, we are going to give the same ranking number. Right now, so leaderboard is already there, right? So there is a player who wants to climb to the leaderboard. So leaderboard is there. So maybe let's suppose he is not on the leaderboard, and now he starts playing the game, right? So he play maybe first game, and then he want to see, okay, now where I stand in the leaderboard. uh, Maybe then he play the second game and then again check, okay, now where I am stand in the leaderboard. He play third game, then again he will check where I stand in the leaderboard. So example, this ranked array we have given, ranked array is the leaderboard array. So if you consider ranked array 100, 90, 90, 80. So 100 means rank 1 because the maximum rank, and 90 means rank 2. This is also 90, so it should be also rank 2 because it's uses dense ranking. 80 rank 3. Correct. So now the player starts playing. So this is the existing leaderboard. Now the player start playing. So 70. So where the 70 will become? 70 will become after 80. So maybe so that's why the player rank will be 1, 2, 3, and 4, because 2 is for 90, 80 is for third, then 70 will be 3, 70 will be 4. So that's why we have to return an array with all the ranks, whatever he achieved during all the play. So when he play the first game, he score rank 4. Okay. When he play the second game, so when he play the second game, we have to use the existing leaderboard. That is which is like the leaderboard which is for the rank one. You can't say no. Now I have the leaderboard which has 800, 90, 90, 80, and 70. No. So we have to use the same leaderboard, and they said, okay, my rank may be worse, so I will play again. Then he start playing again 80. Okay, so now his rank will be improved because 80 will come here, and 100 is for rank 1, and 90 is for rank 2, 80 is for rank 3. So now he score rank 3. Now he play again 105. So 105 will become before the 100, so he score rank 1. So answer will be 431. Okay, so we need to calculate this 431. Let's go through one example. So you have array 100, 40, 40, 20, 10. So does it really matter? Shall I give 90, 90, 90, 90 multiple times? Because anyhow, all the 90s are like just for the same rank, right? Two. If I compare 70 with this 90, then why should I compare the 70 with the next 90? Why should I compare the 70 with the next 90? Why should I compare with the 70 with the next 90? So to solve this problem, is it good we can remove the duplicates, right? So the first thing is we have this array given that is the existing leaderboard. So I just remove the duplicate. So with the if we remove the duplicate, uh, what it will become? It will become 100, 50, 40, 20, and 10. Right. So this will become. And now using this leaderboard, because anyhow, like doesn't matter whether you type 2 times 100, the rank is one. Anyhow, we have to find the rank. So why should I compare my elements 2 times or 3 times, right? So unnecessary wastage of time. So we can remove the duplicate. So first step, even while writing the code, just remove the duplicates. Right, so 150, 40, 20, 10. Okay, so how you are going to assign to the leaderboard? So we are not writing the code currently, we are just trying to analyze how to write the code. So 150, 40, 20, 10. So 150, 40, 20, 100 is for rank 1, 2 is 50, 3 is 40, 4 is 25. Okay, now we have this, the arcade player start playing the game. So in the game one, he score rank 5. So what should you will do? So you will start comparing with 100. Okay, is 5 is greater than 100? No. Is 5 is greater than 50? No. Is 5 is greater than 40? No. Is 5 is greater than 20? No. Is 5 is greater than 10? No. So none of the option satisfy. It means 5 is after this like a leaderboard, which is on the rank 6, because we can count the number of elements or maybe index operator, whatever it is. So we got rank 6. Okay, now so just forget this new rank table. We got the answer 6. So we will return in an array. The first element will be 6. Okay, now for the next game 25, we will check, okay, whether 25 is greater than 100. No. Whether 25 is greater than 15. No. Whether 25 is greater than 14. No. Whether 25 is greater than 20. Yes. So 25 is greater than 20. Where where we are going to place? So we are going to place at this position, like before 20, then 4 and 25. Right. So we are going to place here 4 and 25. So the rank will be 4. Okay, now 50. So again the same leaderboard. Is 50 greater than 100? No. Is 50 greater than or equal to? So second thing is we need to check equal to as well, because they are using dense ranking. If 50 greater than equal to 50, yes. So the rank will be 2. So rank will be 2. Okay, 120. Is 120 greater than 1? Yes, 120 is greater than 1. So what will be the rank? Rank will be 1. Right. So we are going to return 6, 4, 2, 1. So if you go to the code, so 6, 4, 2, 1 will be the output. And here is the like the diagram view which I have just explained. Okay, so what is the first step to solve the problem? First step is we need to remove the duplicates, right? So we will, so this ranked is the existing leaderboard, and player is the player who is playing the game, and the score array basically. So ranked is the leaderboard. So let's find the unique ranks. And how to find the unique ranks? So if you have the list and you want to remove the duplicate, just create a set. So set of ranked array. But when you create a set, all right, so set is an unordered, right? By default it maintain the order, or it's not mandatory it will maintain the order. So because it's one more thing I forget to tell you, the ranked array is always in the decreasing order, and the player are array always in the ascending order. So you don't need to worry, like 100 will be, 100 is always first, then second, whatever the lowest, and then the second, then third, then fourth and fifth. Okay, so let me go to the code. So we need to find the unique rank. So we have to get the ranks. Uh, but this is not uh, because ranked is in the decreasing order, and when we create a set, it's not mandatory it is maintaining the order. So we need to again sort it in the reverse order, so that we can get the same thing. So you will get the unique ranks. Okay, now you need to return the array. So if you see the question, you need to return the array Here as well, you need to return an array. Right, so let's create some array. Array will be player rank. Right, so array will be player rank. Okay, now what we will do, so we will start from our player, like this loop. Right, so for player score in player. Okay, so we'll start from this. So we will pick first element 5. Now we have to compare. We have to check, okay, where we can place the 5. Okay, or not place, we don't actually need to place it. We just need to compare and we need to figure it out, the rank. That's it. Right, so a kind of a practice test, by looking at the actual leaderboard. So 5. So what we will do, so we need to run a for loop on the second, on this one. And when we run the for loop, we should know the index as well, because if you don't know the index, we don't know the rank. Right, so for, you can say, rank comma leader score in unique ranks. So rank, sorry, enumerate. That's why it will give the index. I know, enumerate is going to, because in a Python, array is zero based indexing. Ideally, the rank should be 1, but we are getting rank as a 0. But don't worry, we are going to take care of that. But anyhow, we need, because when we are run, or when we are trying to run the loop onto this, we need the index, you can say rank, and we need the score, so to compare. And wherever we will check, okay, for which position it is greater, and for that we need the index. Okay, now what is the next thing? We need to check if player score is greater than or equal to. All right, because we have the 50, so 50 can be greater than or equal to. All right, so if player score is greater than or equal to, if it is greater, so let's suppose 120. Right, so 120 is greater. Right, so 120 is greater. So what we will need to do, we found the position. Right, we found the position. So what we will need to do, player player rank dot append. What we need to append, rank plus 1, because rank is 0. Because, right, now 0 can't be the rank, because we are in the Python 0 based indexing. But at least, actually it's rank 1. Right, okay, so once we found that, we need to just break it. We need to break the loop. Right, because once you find the position for 5, so let's suppose we are going to check for 50. So you check for 100, you check for 50. Once you know the position, why should I like, check for 40, 20, 10? Right, so why should I run this loop till end? I can just break the loop as soon as I found that, my rank. Right, because aim is to find the rank. All right, so that's done. Okay, why we need the else condition? Because of this one, like 5. So we are checking for 100, we are checking for 50, we are checking for 40, we are checking for 20, we are checking for 10. All the loop has been finished. So this loop has been finished. This loop has been finished, and within this loop only we are updating our player rank. If you are not going to use the else condition, then what will be the rank of this 5? Right, so what we will do is, in the else condition, player rank dot append. So if you will not able to find anything, or any comparison, like as an example in case of 5, because none of the condition met, then what will be the rank? Rank will be the, you can say, the length of the array plus 1, length of the unique ranks plus 1. Right, so length of the unique rank means 1, 2, 3, 4, 5, and the position will be 6. So that's it. So let's try to run the code just to check our sample test cases. Okay, so something is wrong. Okay, we need to return that. Return player rank. Let's try to run the sample code. Mm, okay, spelling is wrong. Player rank or player ranks, it will be better because it is a list. Okay, let's try to run the code. So sample test case has been passed. Now let's try to submit the code. We will see whether all the test case has been passed or not. If not, why not? Okay, this is the simple brute force approach which we have implemented. Okay, we could see 1, 2, 3, 4, 5, 6, 7, 8. 8 test cases has been passed, 4 test cases has been failed, and they have failed not because of our logic, they have failed because of time limit exceed. Right? Okay, got it. Like they have, because we know we are running two nested for loop, so m cross n, right? So m player and ranks m cross n. So definitely, if there are very large input, they are going to fail. And if they have set some time limit, your code should be executed within this microsecond or this seconds, and our code is not able to execute. But anyhow, our logic is correct. Okay. Now, what should you do to remove this timeout error? Still, we are going to follow the same approach. We are not going to do anything. The only like first, I am going to tell you the reason why it failed. Let's go to some example. So we have the rank array 100, 90, 80, and 70. This is a leaderboard, right? This is a leaderboard. So which means this has rank 1, this has rank 2, this has rank 3, this has rank 4, right? And this is the player who is playing the game. So we have 60. Now we know this is in ascending order, we know this is in descending order, and we already optimize it by removing the duplicates, which is totally fine. We have to do that. Now we start with 60 because we start with 60, right? The first player, and we are going to comparing with all the ranks. Okay, so we start with 60, we compare with 100, we compared with 90, we compared with 80, we compare with 70. We could not find any, and then we found, okay, the rank is 5. 65, again we compare with 100, we compare with 90, we compared with 80, we compared with 70, again we could not find. Maybe next is 66, again we compare with 100, again with 90, again we compare with 80, again we compare with 70, again we are going to put that. So it looks we are like unnecessary, like traveling through the array. And now the next question is, without traveling, how you can know, right? Without comparing, how you can know? So just a simple trick. Instead of checking from the start, let's check from the backwards, because we know this is in the descending order and this is in the ascending order. So let's check from the start. 60, is 60 greater than 70? No. So we even don't need to check the whole array, because in earlier case we are checking the whole array. But if you start from the backward, you would don't need to check the whole array, so you save some time. 65, is 65 greater than 70? No. So you save some time, you even don't need to check the whole for loop. 70, is 70 greater than equal to 70? Yes, just place it. You don't even need to check this. If you start from the start, even for the 70, you have to check for 100, you have to check for 90, you have to check for 80, and then you will check for 70. It means we are wasting some time for iterating over the loops again and again and again and again. All right. So that's why they have mentioned they are in the decreasing order and they are in the ascending order. So this it will be still remain okay. So instead of, we have to check for each player, right? So we have to check for 60. So this loop we definitely need. We need unique ranks. We need the array. But instead of the further loop, further loop and we are checking from the start, we will check from the last, right? So instead of this, what we will do is let me do this. We will do while we will run a while loop while p score, while the player score is greater than unique ranks, right? So unique ranks, so we need some kind of index, and what will be the index? Let we have to find any index, so let's suppose j. But what will be the j? We need to start from the last. How we can check? Length of unique ranks minus 1. So unique ranks of j. Okay, so basically we are checking from the end. So while p score is this player score 60. So instead of starting from the for loop 100, 90, 80, 70, we will start from the opposite. So p is greater than 70. So is p is greater than 70? No. So p is not greater than 70. So what you will do? You will let me ignore this for the time being. You will append something, right? You will append something. And currently, what is j? J is j is 1, 2, 3, 4. Not 4, basically 3, because length of unique rank is 4. 4 minus 1 is 3, and we are checking the third index. So you can say this is the ranks. These are the ranks, but index is 0, 1, 2, and 3. Right, so we are checking what we will do is, so j is 3 in starting, right? Or basically, sorry, or basically you can say rank 4 but index 3. So we check for unique rank of j. All right, so we could not find the answer because the while loop failed. While loop could not even satisfy. So if while loop could not satisfy, we know the position, right? So player rank dot append, what will be the position? What is j? Current j is 3. If you just add 1, then it will give you the actual rank of that player. But we need to place that element even after that. So basically plus more 1, so you can say plus 2, right? Because j plus 1 will give you the actual rank from of the element from where the condition failed. And if the condition is failed, it means we need to place the element after that. So that rank plus 1, so j plus 2. Okay, so now, so this condition fails, so even it's not going to enter into the while loop. Now for the second one, 65. For 65 itself, so let me remove this 60 because we have to always compare with the original leaderboard. 65, is 65 greater than the this element, the last element, 70? No. So we are going to append that. Okay, 70, is 70 greater than or equal to? Yes, 70 is greater than equal to. So what we have to do? Player ranks dot append. So we need to append the rank. So we know it is greater than or no, we even don't need to append that. Just ignore that. Just ignore that for the time being, because it is greater than. Maybe it is 72. Like we have to check the another element as well. We have to check 80 as well. Right. So 70 is greater than 70, but we can, like, by manually seeing we know 70 is greater than 70. But let's suppose if it is 72, we know 72 is greater than 70, right? So we have to check for the another element. So if you go previously, you have to do j is equal to j minus 1. You are going backward. So now you will check for 80. Is 72 is greater than 80? No, right? 72 is not greater than 80. So this condition fail. This condition fail. If this condition fail, we are out of the while loop and we will append the player rank. So where it failed? On index 2. What is the rank? J plus 1, 3. And where it failed here, so it means the element will come here. So where it element will come at 4. So J plus 2. Okay. So this looks okay, but we need to add one more condition because this is a while loop. Right. So let's suppose for the element 105. Right. For 105, we will check with 70, 80, 90, 100, and then because it's still greater than 100 and loop is finished. But here you need to finish the loop somewhere, right? So you have to set while j is greater than 0, and that's it. Let's try to run the code. Okay, something is wrong. 6422 we are getting, but the expected output is 6421. Greater than or equal to 0. Yeah. And let's try to submit the code. Let's see if just by doing a small tweak, instead of reading from the start, we compare from the end. Will it work? Yes, it works. Now all the test cases has been passed. So hopefully you understand the problem. Problem is still same. You anyhow, doesn't matter whether you start from the top or whether you start from the down, you have to compare it, right? So even when we running for loop, right? When we are running for loop, we are comparing from the top anyhow, and still we are appending the rank. But we observe some test case has been failed and we figure it out. Okay, this is the test case and why it failed, because unnecessary it is comparing again and again and again and again. Right, not particularly this test case because this is very small test case, but some kind of this test case, but with a very long input where mainly most of the elements are after that. Maybe let's suppose in the player array we have 1 to 69, so all the elements will become after that only. So why we are unnecessary compare with these four, right? Then we figure it out. Okay, so what we can do is we can compare from the last. So we will just do is like, okay, let's trying to compare from the last. Still we are comparing and we are appending, but we start from the last. So that's it. That's the end of the video, and thank you.